Hi, everybody. Is everybody ready to get started? All right, as are we, so that's perfect. Second from the last of the day. This is terrific. All right. Well, welcome to Background Execution in a Windows Task. I am Jerry Nixon, developer evangelist for Microsoft. I live in Colorado, just north of my friend here, Michael. Michael, who are you?
Michael Palermo, also developer evangelist, live in Arizona, and really happy to be here to be with Jerry. It's awesome to be on stage with Jerry Nixon. He is a wild guy, as you're going to see in this course. And in fact, I think it's awesome that you're all here, because if you think about most of the sessions, someone can usually demonstrate some ooh and ah, and there's some eye candy. You're here for background execution. There's no glory in that. It's like the wind beneath your wings. You know, there's nothing exciting about it, but we're going to make it exciting.
That's right. I mean, that just because it doesn't look dazzling and sparkle doesn't mean you don't need to applaud occasionally. Just think about that.
That's right.
Not yet. We haven't done it yet. Well, yeah, just get used to it. That's going to be great. That was a sad set of applause.
Yeah.
Don't ever do that again. All right. Okay, so where are we heading? This is for Windows applications, right? And Windows applications have a whole set of properties and capabilities that we're going to talk through, including their life cycle and what's unique about the life cycle of a Windows application and how it maximizes the battery and the performance of a device. Also around background execution and what we have today, and then sort of how that is going to change in the future. There's a lot of things coming and a lot of enhancements, especially around the way that background tasks used to operate in Windows 8. Windows 8 had a whole set of constraints, many of which have been lifted or at least laxed a lot. So we'll talk about that together. The great news is you're building Windows applications. And the fantastic news is, because it's Windows 10, targeting the Universal Windows platform, it means it'll run on every device that'll run Windows. And so that's a big deal.
And has that messaging been lost at all? I'm just curious. Anyway, continue.
We announced it now, right? That's right. And so this is great. And so everything we talk about here is not specific to any device. Everything we talk about here is universal across all the different devices. That being said, not all devices are made equal. It might be that you could actually melt down a machine with the background task if you're not careful. So you will definitely be able to think that through. All right, it's sort of now, this is sort of a look back. And if you are, in fact, let me ask that. I'm curious, how many of you have acted on File New Project, and you have created a Windows application once? Oh, well, that's fantastic. I won't ask who hasn't, because it could be the same people.
Sure.
All right, so that's fantastic. So this might be old news to you, but for the 2 or 3 of you that didn't raise your hand, we'll go ahead and talk through what the life cycle process is for a Windows application and why it's special. Right? And so let me just start by saying this. When a Windows application is running, it's running. Right? It is full-fledged, all on. And it gets the most performance possible from the device so that the user has a great experience. That's what we want to give the user, a great experience. We don't want to kill their battery. We don't want to lag. We don't want to do all these different things. And over throughout the framework, you'll see all these decisions being made to make the user's experience better and better and better, even if it translates to a little bit more work for you and for me, the developer. That's just the way it works, because we want a better experience for the user. That being said, as soon as the last pixel of your application is no longer visible on the screen, then you are no longer scheduled for processors. No longer scheduled for execution on the processor, right? It is over. Your application is no longer running. And so that's how it's different than a regular Win32 application, like a WPF application, that runs regardless of the fact that it's in the background, right? As long as you can see it, it's running, and if it's not, it is, but that's not the way Windows applications work, because users will run this on devices that don't necessarily have much power or battery, and it will stack up. And you don't want all 52 apps that are stacked up to be sucking up all the performance of the user so that you on top look like the worst app ever, right? Because that's not the way that we want the user's experience to be. We want it to be terrific. And so that's part of it. So look at this drawing. This explains really the 3 states that an app can be in at any time. And so it's not quite as dramatic as I made it sound. The reality is we start at the green side here, and you're running and your application is great. And all of a sudden, the user goes to check their email or something like that, and they swipe over, and your application is no longer visible. Well, as soon as they do, your application receives a suspending event. And that suspending event is a warning to you that your application is about to be halted. Not terminated, that's not quite the same thing. It's about to be suspended, right? And so you have this short amount of time when the suspending event will fire that you get to quickly act. Save data, save state, do whatever it is that you need to do really quickly. Time's up. Now your application is in the blue box, and the blue box is your suspended state. Nothing is going on. It's not that you get just a little bit of processor. You don't get anything at all. Your application is fully suspended. Now, that's great. Your application is on the back of the stack. Think of a deck of cards, right? Your application is a few down, and then a few more down, because the user keeps playing all these games, and then they start opening all these apps, and they're doing all these things, the way people use their devices. All of a sudden, your application is pretty far down the stack, and to be honest, your application takes up a little bit too much memory. Okay? It's no big deal. All the operating system is going to do is sort and figure out who needs to be terminated, and your application is terminated. The terminated event inside your application will never raise. Why? Because your application is suspended. There's no way it could respond to an event even if it were raised. So now your application went from running to suspended, and then it went to terminated. And as it went from running to suspended, you got an event. Terrific. As it went from suspended to terminated, you didn't. Now, you could have gone the other way. That's the other arrow here. And you could have been resumed back into a running state. Now, you don't have to do any work at all, as a matter of fact. There is a resuming event if you want to do something. But you don't have to. That fast switching is automatic inside Windows, and everything goes fine. But you can also be run again after you're terminated. The user would just have to tap on your tile, right? You would no longer be in that list of apps that are running. You would be completely gone, and they'd have to tap on your tile. As soon as they do, your application runs, no problem. You have a whole bunch of things you need to do now, because honestly, this is the first time you've been run. And so now you can ask, hey, was I just terminated? Because that's one of the things that you're passed in. And you're like, yeah, you were just terminated, so you might want to give them a better experience than just starting from scratch again. And you can. But nonetheless, this is the life cycle of a Windows application. Running, suspended, and terminated, and you get to manage where you are and how you work inside each of them.
And I would probably say, if you look at the boxes over there, green means you're alive, and maybe it's a morbid analogy, but once you get into the blue area, you're on death row. You know, it's going to happen anytime. If you make it over to the purple or pink area, then you've been terminated, right? So remember that analogy, because there's a couple things that will come up that will help us to know what can happen to people on death row. There might be a saving chance for some things. So let's see what happens.
So across all of this is your background task. So this is your foreground task we've been talking about, your application. That is its life cycle. But a background task has a different life cycle, and it has nothing to do with the state of your foreground app. So your foreground app is suspended, running, terminated, whatever. It doesn't matter, and that's what we're talking about today. Background tasks. All right. Here's the application lifecycle, and this might help us as far as just being nerds about it. And so just imagine memory is here on the y-axis, and then along the x-axis is kind of a manner of time. And so your application starts, this is the launched right here, and it goes up and takes its full amount of memory. Maybe it doesn't. You know, it takes however much memory it takes. And it starts to run, and everything is good, and the user is now going to suspend your app. They can't say suspend, by the way. They suspend it by going to something else, right? And so what they do, they go to something else, and now you have received this suspending event. So that's down here, right? Your suspending event occurs, and the blue section is about to begin. The blue section is the 5-second window. 5 seconds exactly. The 5-second window that you have to save your data or do whatever, and then you go into the black state. Now the black state here is your application still alive. It just happens to be suspended. So you still are taking up memory space, right? And you run and run and run, and then you're reactivated. The user comes back in because they want to play more of your game. And as soon as you're activated, it's similar to your launched, but it's an activation state. And so now you're reactivated. You go back up to consume the memory that you had to take, and go along until you're suspended again. 5 more seconds happens. Now you're suspended and you go back into the black state, right? Still taking up memory, but your application is no longer running. And then suddenly you're terminated with no event, right? Maybe this will just help drive it in, because driving it in is the goal. So when suspension occurs, it's important for you to know that there's a lot of ways for you to handle it, and the main way is to handle the suspending event. So suspending event is the top-level app event that occurs. And so at that time, you jump in to do something. The problem is, if you're going to save a bunch of data, it might take more than 5 seconds. It is not a best practice to wait for the suspending event to save everything. The reason is 5 seconds is a hard number. You do not have 5.5 seconds. It means if you're in the middle of an operation and it's still not complete and you get to 5 seconds, your operation gets interrupted and you don't complete the transaction. That's just the way it works. If you know that it's going to take 6 seconds for you to save your data, then all you have to do is save data along the way. As the user is navigating from page to page, moving from form to form, doing all these tasks inside your game, whatever it is, just save those along the way so that the suspension event is actually quite quick. You just save the last little bits that you haven't saved so far. Makes sense. Resuming is just up to you depending on how you save it. And so this is all in the app.xaml.cs that you're doing. These are the same events as a JavaScript application, by the way. I just am a XAML guy, so that's the way it rolls. In fact, that's an interesting question, Michael. How many people would say, let's just start with, how many people have ever coded with using XAML as the UI? That would be everybody except for 5 people. Okay. How many people have ever used JavaScript? That would also...
What?
That would also be basically everybody.
It's
a little less than I thought it would be. I thought I was asking an easy one there. Okay. If you haven't used JavaScript, I don't even understand that. But just let that roll. All right. Background task scenarios. Why would you even have a background task in the first place? What are you planning on doing? Why do you need to run when the user's not using your application in the first place? And the first answer is you don't. There are very many scenarios where this is not for you, right? If you're writing the ultimate calculator, then you probably don't need a background app to do all the calculation because the user's not looking at your app in the first place, right? There are some apps it just doesn't belong to. But what if you have an application with a bunch of live tiles? You have information that you're presenting on the start screen and you love having the tiles up to date. That's the perfect use of a background task. So you create that. So even though your app isn't running, you still give them a terrific experience. Perfect. Another one might be toast notifications. It's time for you to do something. It's time for this to occur. This just happened. There's a tornado on the way. Whatever it is, and you want to somehow alert the user, a background task is a great way to do it. Maybe your background task wakes up and it checks to see something on your server. It finds that it's true. It sends a toast notification. That's terrific. Or maybe it just wakes up, works out something and says, hey, it's been more than 12 hours since you've opened my application. I think I'm going to beckon you back in, right? A lot of games use that technique. And so that's kind of the way it goes. Another one might be around brokered tasks. So I would use a background task in order to transfer a file. This file is gigantic. What if the user closes my application before I've finished downloading it? Now I'm never going to download this 16 gigabyte file for them. Well, the problem is that you're right. So a background task is perfect. I can queue up background transfer tasks. They run in the background without any regard to the state of your foreground application. And finally, what if you use an app service? So this is new in Windows 10, and it is unbelievable. What if you have data in your application and you want to expose it to other applications? And you never want to launch your UI, right? They've installed your application. You do have a UI. That's great, whatever. But you want it to be consumed. So you can expose a background task as almost like a web service so that other applications can call to your task as if it were theirs, ask it a question and it will give it an answer, right? Ask for data and it will give it back data. Ask it to process something and it does and it gives it all back. And I can centralize all the activity. Maybe I do that for authentication. Maybe I do that for some sort of... So think about maybe I have an application. I write the Facebook application. It keeps all of my... status updates in it. And I have all these other applications. They love to show statuses too, but they don't want to call out to the Facebook app because that's too heavy. That's okay. They call to your application and you give it to them through app services. So that's another use of background tasks. And that's a new one in Windows 10 and it's fantastic. It's fantastic, Michael.
It is. I love this right here because this is why I was saying, why are you here? Because if you look at the first part, these background tasks, they are invisible, right? So there's nothing to show you. But that is kind of the key, is you have to keep in mind, we're not talking about something that you interact with. This is something that's behind the scenes.
Yeah, that's right. And so these are the principles around it, right? That they run regardless of your app state is super important. But that they're short running and quick is going to be very important for you, the developer, to know. And we'll talk about quotas, right? And one of the quotas is going to be time. They only have a certain amount of time to run. And that's it, right? And that's important because I may have many apps. They all have background tasks. They all want to run. They all get to run. But I don't want them all to constantly run. So everybody has certain quotas to make sure everybody plays fair and takes turns on the swing, sort of thing. Perfect. All right. The other thing around a background task is that, isn't that interesting?
It is. Huh. You just got a star.
A gold star just appeared on my hand. It's really wild. Is that background tasks, just like your foreground application, have access to almost all of the APIs that you would anyway, with the exception of things like camera. Wouldn't it be awful to have a background task that turns your camera on, takes your picture, and goes back to sleep? That would be, you might think it for a second, you'd like to write that app, but wouldn't you hate to run that app? Wouldn't that be the worst ever if you didn't know it actually would? So, I have no idea why that would be a problem, but I'm just saying wouldn't it be terrible?
These are words of wisdom.
This is the mantra, predictable behavior on every device. The goal here is to make sure that every user has a great experience. What predictable behavior do we want them to have? We want them to have a terrific experience. That's the behavior we want them to have. But we also want your application to behave the same on every device as well. And so we give it almost a common denominator, and then you'll see there's also gateways to make sure you leverage all the hardware that's at your disposal too. So that's kind of nice. All right. So we start with extended execution. Extended execution, brand new in Windows 10, and a powerful thing for you to be able to use in your application. Remember, when the user decides to suspend your application by doing another activity, you have 5 seconds to save all of your data. Well, it just happens to turn out that Windows has a global pool. And the global pool of resources is there to make sure that if a whole bunch of apps are suspending at once, if a whole bunch of background tasks are running at once, and it's just the way it happened, that the system doesn't become overwhelmed. They can dip into the global pool of resources, a small reserve of resources that you can kind of use to make sure that as you have tons of things happening at once, your system doesn't explode, right? Well, there's now, in Windows 10, there's now a formal way to ask for part of that extra resource, and it's called extended execution. What it allows me to do as a developer is to say, hey, I was just signaled to suspend, and I need 6 seconds. And the system will give you an answer back and say, no, right? And so you lose it, right? But you know that, right? Because it told you no. I only have 5 seconds. I needed 6. That's the way it goes. I'm going to write a note in the log, which will take less than 5 seconds, to say data was lost, right? And we'll take care of that when we launch back up. But the system can also say yes. And it can say, sure, I'll give you extended time. No problem. It turns out that the global pool, there's tons of resources. Go for it. And now all of a sudden your application gets extended execution. And you start to run, and you have all this extra time, and there's going to be an event that does fire that eventually kills your process, right? You don't run forever, but you get a nice long time, as much as you really need, until resources are so constrained that it has to kill your application. This is particularly valuable for apps that run on desktops, where there is plenty of resource, right? There's no way that I'm going to run out of resources. Why are you making me do this in 5 seconds when I know I have more than enough time to do it? Why don't you just give me a way to ask for all those extra resources? Now you have it through extended execution, right? That's the idea. However, that's the reason it can also say no, because my application can also run on a Raspberry Pi. My application can also run on HoloLens or anywhere else that I want to, where maybe that pool of resources is actually too lean for you to be able to do anything else, because what it's trying to do elsewhere that's causing you to be suspended or terminated is something far more important, and we want the user to have an excellent experience with it. Okay, so that's the first one. I have data this time, right? I'm saving. I need to save. Can you give me more time? Yes, terrific, I'll save it, right? Or maybe you'll save partial if they say no. But then there's the other one. I'm a very special kind of application. I am a turn-by-turn navigation application. And when I run, if the user's not looking at me, they still count on me. So don't you dare cancel or terminate me, right? That doesn't even make sense. So we have that, right? You can go in and say, this is who I am, and I'm a, what is it actually called? Location tracking?
Location something.
Yeah.
We have a slide on it.
Yeah, there's an enumeration. You'll pick it. We all use IntelliSense. Okay, so if you would specify that you're this, right, now all of a sudden the regular activity of the user that would have caused you to be suspended is ignored, right? And now you're not suspended at all. That being said, your application is always subject to the user's experience. If the overall performance of the operating system is so degraded that the user cannot use it and it's not being good, the operating system could have a heuristic inside it that determines your application should be terminated even though you're special, right? They have so many things running, so many things are going on, desktop applications, the memory constraints. Your application can't even run based on the way it's going, so it gets terminated as well, but you get a notification all the way around. So, another special kind of app might be if you're a VoIP application as well. So there's always this balance, right? There's always this balance. How fast can we get this application to load? And how much time can a developer actually have to suspend their application, right? You're going to end, you're going to start. Well, it's a different application that's starting, and your application is ending, so you want more time, and you want to take away from the application that's starting. But now your application is starting, so you want to launch quickly so you have an awesome experience in your application, and you want to make sure that the previous application isn't degrading its performance. You can see the balance. And so all these things, when you see these constraints, just remember there's this balance that we are constantly trying to put together. Maybe it'll make sense as a graphic. There's two types of extended execution, don't forget. The first one is the ability for me to say, I need more time. So that's the time right at suspension. So here's my application running, right? This is the green block. I'm running, everything is good, and all of a sudden the user suspends and I've got 5 seconds. At that very moment, I'm going to detect suspend because the event is raised, and I'm going to say, quick, I'm going to request extra time. As soon as I do, I don't get any UI or anything like that, but I do get a memory space to execute inside of. And so now I can run for as long as I need to until I finally get a revoked. That's the one at the top right. So once I'm revoked, that's the final event that occurs that says, you got 1 second to clean up because there's some business going on, right? And so then something needs to happen from you, the developer. You could do a couple of things. 1 second's all you need, and you're done. That's great. 2, well, 1 second's not enough, and you're going to be caught in the middle of a transaction, so I'm going to write to my log and say that it was not completed, right? Just like you would have before. But at least you had the option. It just didn't work out because the user decides they're going to run Minecraft or something on a phone. All right, that's option number 1. Kind of lays it out. Hopefully that makes sense. This is the syntax if you want to do it. So here I am inside my suspending handler, my onSuspending. And so the way that I handle, the way that all of us handle suspending is to make sure that we capture a deferral. And so here I am going in and saying, okay, this is a suspending operation, I'll get the deferral. So what's a deferral? A deferral says that I'm going to execute an asynchronous operation in a second. It's going to release this method, and as soon as it releases, I don't want you to think I'm done and go ahead and terminate me early. What it really says is, I'm working hard, just leave me alone. I'm going to come back to you later, and I'll complete this deferral, right? And so the deferral is a don't close me right away sort of thing. Yeah. Then here's the actual execution syntax itself, where I'm requesting to be extended. So I can say session.request extension async, and then it returns an enumeration that's it either allows it or not, right? And so if it does allow it, then I'll go ahead and, if it does not allow it, in this case it's denied. If it equals denied, then I'll do the 3-second save, because I know I've got 5 seconds, that gives me a little wiggle room. I'll save just the basics and go from there. But if it says I'm not denied or I'm allowed, then I can take more time. And it still may not work, right? I still could be terminated if it had to be, but let's hope I'm not. I'm going to go ahead and take that extra time. On a desktop, this is a beautiful experience, because on a desktop now I get to leverage all the resources that are sitting there anyway.
So that revoked that you see there under the session description, do you recall he only has one little line in there? Why is it that he only has that small amount? How much time does he have? Do you remember? 1 second. So that's all he has there. The reason why he's gambling on the 3 seconds being okay is, remember how many seconds it was when we're suspending? 5. So that's why that 3 seconds makes sense, because we're finding this out right at the beginning of that suspending. Okay, how much? Oh, I think we can do this in 3. So that's kind of the logic there behind this kind of extension.
Yeah, that's right. So the other kind is when you want to extend well, that was the extending the suspension. The next kind is when you want to extend the overall and prevent extension. Did I have this backwards? I can't tell. I think that was talking about the last one. Doesn't matter. All right. So here's the other type. So instead of asking at suspend, see, suspend is way down there. I'm asking right when I start running, right? I know that I'm a certain type of app, and I want to set things up.
You're asking to extend at the beginning of the app running? Is that what you said?
Yeah, that's exactly right.
Why would you do that?
Well, because I'm a location tracker, right? And I don't even want to mess with the idea of suspension. I want to go ahead and identify who I am, and I want to make sure that the system then handles it for me from that point forward and never monkeys around with giving me suspension. It doesn't mean I won't be suspended, by the way. I could be if systems really get tight, right? But hopefully that never happens. So instead, whenever somebody navigates away, and so that's where that dip is, and I would naturally have some sort of suspension occurring, it doesn't happen. It does mean I don't have a UI, but what it also means is that I have a memory space in which to operate that is reliable now, right? So I keep on going, and then I get suspended later if I have to. I may never be. The user comes in, comes out, comes in, comes out. I'm never suspended. So that makes me a location tracker, of which there can only be one on a system. And that you write Notepad and you say I'm a location tracker, it's going to, that's fine. The user is going to approve it, so it's kind of crazy, but that's how it works. You can't have 16 location trackers on your app, on your system at a time. Yes, sir?
Yeah, I was going to ask a question on how you prevent app developers from using this capability.
But I just answered it because I knew what you were going to say. Yeah.
I was going to say, is this what we would use if we were doing, say, a video processing app where, you're going to want to have the CPU for, 15 minutes, but we won't actually, we want the user to still be able to go run other apps while we're doing this background work. Is this what we would use?
No. All right, so the question was, so the question in the back, just in case nobody heard or the recording doesn't hear, was what do we do? How do we prevent people from abusing it? And you can't, right? That's the reason the user gets to see what the app is doing. That's true with a lot of capabilities. Like how do you keep a developer from abusing the camera, the webcam? That's because it's a capability the user gets to approve. But his question was more of what if you're doing video processing and you want to process a big chunk of video? Is this the way you do it? You just fake it and say you're a location tracker and then you just keep on running? And the answer certainly is no, partly because this is meant for location tracking and it does mean you might actually bump the actual location app that they have running. But the second one is because there's other ways to do it. So we have background tasks, and we'll talk about it in a second, that can be triggered for the purpose of handling media work, right? And so I need to do this, but I can do this in a background task that does it for me, that's dedicated to that. And that's it. That's really the whole thing. So could you do that, what you just said? I think technically you could.
You can cheat. You can
but that's,
try.
yeah, I don't know.
Background tasks, but they're limited on their CPU, right, usage? So you said there's a special type of background task, though, that...
Yes. Everything is limited on it. No. All right. So he said just then, oh, I've heard of background tasks, but they're limited on their CPU, so that wasn't appealing, right? Let's be clear. No, that's not the truth. So, not truth. That may sound you're lying. That's not accurate. I'd rather be wrong than a liar. So, the background task has a guarantee of 10% of the CPU cycles that are going on, and any of the others that can manage to sneak its way in. So it has a minimum, but not a maximum, right? Yeah. I'm sure it has, there's a practical maximum that if your background task is taking up everything, the operating system is going to nuke you. But that's different than saying it only has 10%, right? Which is what I don't want you to see. All right, so this is part 2. This is the one where we say, never suspend me. Mm-hmm. And for the most part, you'll never be suspended.
Right.
Yeah. All right, so preventing termination. Yeah, we put these at the end. They're so wise.
That's all right.
All right, so here's the syntax on how to do it.
And in fact, what this code is like, we saw the code before where we were in the suspending event, and we were asking for that extension. But if you look now, the name of this method here, it is asynchronous, but I made it up. It's some method that I'll call near the very beginning of this app being launched. And I'm doing that same kind of request, though, down below where I'm asking for that extended session. But notice that I'm using this._session. That's because we're maintaining a local variable or field in this class in order to reference it. And therefore, you can see that we are the location tracking. That was the enumeration you wanted earlier.
That's it.
And then we have to actually still check to see if it's even allowed. Now, why would that be the case? Why would be allowed or denied?
Boy, that's a great question. Why would it be denied? Well, let's see. Gosh. I'm on the next slide. Why would it be denied?
Well, the thing is that what if you already had, let's say, an app that was running that was already, as you said, using the location tracking?
Oh, thank you.
Or
yes.
what if you're on certain devices where maybe there's some contention or whatever? So if whatever the reason is, you want to know right up front if you're not going to be able to do that.
That's right.
And so the other thing, too, is that you want to be able to know, you want to be able to tell yourself. It's just like when he had the slide that was showing, I need to save something to the log to know this or that. Well, you're getting that information. That's why we put the to-dos there. Because it's like, well, what are you going to do if it is denied? How would you notify yourself? How would you communicate that? Or if it is allowed, what kind of things are you going to turn on so that you know that you have that capability?
That's right. That's right. You'd be denied if the location app is already running or another location app. You
Exactly.
don't just bump it.
That's
right. That's right. And where the to-do denied is pretty important because your application may rely on this. Think about Here Maps. Here Maps is going to have logic just like this, right? Where you go in and you're like, okay, give me directions. They're going to pop up and say, I can't, because you've got something else giving you directions. You're going to rely on me, and I'm going to be terminated. So let's not go down that path, right? You've got to do something for your application too, if it falls into this scenario.
Yep.
That's right. So here are the actual enums, right? You can go into F12 and find them yourself inside Visual Studio. So whenever it is extended, that location tracking is there. And then there is saving data, right? That's kind of a generic reason that you're extending your session. And then there's nothing after that. But there could be more, right? And there will be more. They just haven't implemented all of the different scenarios yet. What we have now is location tracking. And so when you do attempt to get permission for that extended execution, so you'll only be allowed or denied. There's no extra piece. There you go. Excellent. Okay, so we talked about this, but I'll just remind you that there's a global pool of resources, and this is the formal way of asking for things from that global pool. You might be allowed to tap into that global pool, which is more than likely if you're on a desktop with tons of resources, but you might be denied, which is more than likely if you're on a very small, like 256 megabyte phone that won't have a lot of extra resources just to hand out to you.
And you know what? So far, all we've really talked about is the application lifecycle stuff. We haven't really even dived into this topic yet, which is really cool. So all we're talking about is what are we going to do to try to preserve things or control things as it's shutting down or resuming or requesting that extension. Now we're going to kind of get to some fun stuff here with seeing what a background task is all about.
So as a reminder, the reason that you're doing this is so you can execute while you're suspended. It's very important to know that once you're suspended, you still want to do some things. There's so many things you can do, and really background tasks are your only option. With maybe the exception of like scheduled tile updates. You know, that looks like you have background activity when it's not. All right, so allowing your application to run when it's not running. And so we have a quick demo that I kind of want to show you just so you can get a feel for what it's like to build background tasks from scratch. So I'll do the whole thing so we can build it from scratch. I will create a blank universal app here. Oh, I hope it didn't say put it in source control.
Did you choose JavaScript?
I did not choose
okay.
JavaScript.
Just curious.
Now, this is the longest I've ever had to wait to create an app, so that's pretty awesome in my entire life. All right, well, let me tell you what we're going to do, because surely it will create blank. How complex is blank? Yeah. All right, can everybody see the font okay? Just kidding. All right, so this is a simple enough app, I hope you think right now, because it is. I'm going to create a quick UI because I want to invoke it. And so I want to invoke it because this is a new way you can invoke a background task from the foreground task. Before Windows 10, this wasn't possible, but this makes for a terrific way to demonstrate what's going on. This is called an application trigger, and it's pretty terrific. So I'll just add a quick button. This is the button. I'll add the other so it doesn't say but.
XAML's easier than I thought. Yeah, that's pretty cool.
Yeah, it's really easy. Yeah. Did you know I have a beginning XAML session?
I do. I'm going to attend it, actually.
All right, so I'm going to create a second project. Your background task is not a class. It is a separate project. Not just any kind of project. It's a Windows runtime component. Right? That's the important part, because it is not going to be invoked by any framework or any runtime. This is going to be run by Windows. That's the reason we create a runtime component, because Windows knows how to use those and invoke those without any problem. I'll call this background stuff, right? And the reason I say background stuff is because I can create more than one background task if I need it. Your application has almost, let's say there's no practical ceiling to the number of background tasks that your application can have. You need to do a whole bunch of stuff. Yeah, that's totally great, right? Each of those background tasks we'll learn has its own quota and constraint, but it doesn't mean that you can't build it like that.
And one thought there, too. You notice that he created that C# Windows runtime component to be this task. Just know, too, for those of you that raise your hands and we're creating some apps with JavaScript, you can also reference that C# runtime component in your JavaScript app.
So all I have to do is create a class inside my component here, right, which is just like a library, right? It's just like a C#. Seriously? Gathering suggestions? Wow. Only during a demo. Isn't that terrific? All right, so that's what it is a magic keystroke, though, I'll tell you. It's Control period, right? That's the one that allows you to get to the smart,
That is strange.
It's not that long of a demo. It's going to be a long demo, but it wasn't meant to be. What's that? It's still gathering. Well, let me talk to you just for a second about it, the application trigger, just so we understand it. It means you have a foreground task and a background task, and it means that your foreground task can invoke your background task. Terrific. Remember, a background task it does not care about the state of your foreground task. That means your foreground task can say something along the lines of, hey, background task, I would really appreciate it if you would go synchronize my inbox for me. Your background task says, okay. Meanwhile, the user goes to play Star Wars Commander, which I'm really giving a lot of play to lately. But anyway, so they go to play Star Wars Commander. That makes your application suspended. But what's terrific is your background task continues because it doesn't care about the state of your foreground task. Now your application trigger, which is what caused your background task to run, continues to synchronize your inbox all you need to. The user relaunches your app later, and you're fully synchronized, even though you certainly didn't have enough time when your application was running.
I don't know. We got some other things that might be blocking. I don't know.
Visual Studio doesn't work with Skype. Would that be work? Well, it works great now. All right, so that's terrific. So your class that you have in your background component is an interface of iBackground task, and when you implement it, it only has one thing that you really need. So in this case, it just has run, right? That's it. When your background task is invoked, it runs this. You put all of your logic here. Remember, don't put UI logic here. That's the one thing you can't do, but you can do pretty much everything else. So here I might launch, or let's see.
Now, when he says you cannot do UI logic, that just to clarify that too, you might think, well, what if I want to update a tile? Well, that would be okay, but you're not making it an immediate thing for the end user to see. But you can update UI type stuff. It's just not going to be immediate to the user. It might be immediate to the tile, but not to. It's not going to cause any interaction with the user.
So I posted in a quick a method here just to send a toast, right? This isn't about how to send toast, so I'm not going to go through that. But I want you to know that I can send a toast now by calling this method. So instead, that's all my runtime. All I'll do is I'll send a toast, and I'll say hi from the background. There we go. Hi from the background. Yay. Now, this is what we call a fully implemented, ready-to-ship background task. It's totally ready. And it hasn't been added to the background task registry yet, so it's not ready to actually run, but I mean, functionally, it's implemented, right? So I'm going to go back to the button click handler on my UI. Remember we created that button in XAML that was really easy?
Yes.
And now, in that, I want to do a couple of things. There's two things I need to do. The first one is I need to register my background task to make sure that that Windows itself knows that it's there. Once it's there, everything is good. The second thing that I need to do is just invoke it. And I can use any trigger that I need to use to invoke it, but because I want to manually invoke it, I'll use the application trigger, which just means the foreground can activate it. But in order to do anything inside Windows, the first thing you have to do is give yourself the capability to do it. If you want to use the internet, you have to ask for that capability. If you want to use the webcam, you have to ask for that capability. If you want to have a background task, you just have to declare that capability, right? And so here we are inside the app manifest inside my application. This is where usually, this is because of the state of Visual Studio right now, right? We're still in preview for Visual Studio 2015, or release candidate, and it doesn't have an editor for the XAML or for AppCS or
The application manifest.
Application manifest, but it will, right? It just doesn't right now. So I get to type a little more XAML than I usually would, but it really helps you guys to see kind of how it's laid out. So if inside the application where I'm defining it, the first thing I add are a set of extensions. I'm going to add one extension, and it's going to ask what its type is, right? So it's runtime type. It is a Is it a category? Yeah, it's a category. Sorry, it's category. All right. So the category in this case is so much easier when there's a GUI. Let me just tell you right now, it'll be great. So I'll go in here. I'll say it's a Windows background task. Right. That's all it is. And then I'll say what its entry point is. And the entry point is basically the name of the class inside my component. So entry point. It is going to be background stuff. backgroundstuff dot my background task. Next time, let's name it really small.
which implements that interface, and so it knows how to call it.
That's right. And then here, inside background tasks, I am going to say it has a task, T-A-S-K, and its type is, and in this case, I'll say it's a system event. So, again, this is all handled for you in the GUI, but now you get to know what the GUI's been doing for you all this time. It's been adding all of this XML for you. So now I have registered this background task and where its entry point is. The entry point is probably the most important thing to get just right. This is the declaration to give me the capability inside my app. So once it's there, now I can start to register it. Then I can trigger to cause it to happen. So in order to register it, it is the background execution manager. Background execution manager. And I can request access. So this is asynchronous, so I will make sure we await it. You can't await it inside a method that's not async, so I'll add those two. All right, so what is this request? This request is to say, I am about to give you a background task, can I? Right? That's really where we're headed. And Windows can tell you different things, right? It can tell you no, and it can tell you yes. In fact, let me give you a switch statement so you can see it. Yeah, right here. And so I can get 4 possible responses back. I can get unspecified, which could mean all kinds of different things, right? That's kind of the catch-all. But I can get 2 versions of allowed. They both have to deal with whether or not this is a connected standby supported device or not. And so basically that is a yes, right? Both of the allowed, terrific. But I could also get it denied. And there's a lot of different reasons I can get it denied. And it kind of brings up a couple of things that are interesting about background tasks. And it goes back to this philosophy of maintaining a great experience for the user. If your background task has an error, which all of ours have errors from time to time, that's no big deal. However, if your background task has an error twice, that's okay. But as soon as you have 3 strikes against you in a 24-hour period, your background task will be unscheduled, and it won't be allowed to run again, right? And so now, when your app runs again, you can reschedule it, right? You can try one more time. But it's important to know that the system won't tolerate too many failures until it finally just pulls you out of the background schedule altogether. So we're going to assume that my access is fine, which I think is reasonable. And I'll say var task equals new background task builder. So a background task has to have 3 things in order to work. Well, it really only has to have 2 things. The first one is it has to, because of logging, has to have a name. So I'll say my task. Another thing that it needs to have, and this is the most important of all, is the entry point. And the entry point, in order to get correct, has to be a perfect spelling of the namespace for your task, which the easiest way to get that is to ask for the type of and then turn it into a string, right? So I can say type of, and I can say background stuff, but I don't see it because I haven't referenced it inside my project yet. So if you're going to interact with it, obviously, just like any class library, you have to make sure it's referenced inside your UI. So I'll go here and say add, and there's background stuff. I'll add it to it. And so there's background stuff. It'll be in context now, and I can see my task right there, and I can turn that into a string. And now I know that my entry point is typed perfectly. Another thing I can add is cancel on condition lost. This means that when I say my task can only run when it has internet access. What if I don't have internet access anymore? Do you want me to cancel it for you? I can give it a true or false here, and we'll talk about conditions here in just a split second. So finally, here's my task without a K. There is my task. The last thing I do now is I determine how I'm going to start my task. Right here is the registry for the task. So in this case, I could say things like, whenever the time zone changes, this is the old perfect canonical kind of demo. Whenever the time zone changes, I want my task to run, and then I can handle whatever the time zone change might mean to my application, right? Or, and the list of triggers that can cause it is really long, we're just going to go straight to the application trigger. So here I say, let's create it separately. I'll say var trigger equals new system trigger. And then in here, we select which of the enumeration we pick from, including the application trigger. Is application trigger a separate one? Silly Jerry. All right. How did I forget that? Oh, most obvious thing. All right, but we could create other ones and they'd be in the system trigger. All right, so this is us creating an application trigger, which is basically saying simulate all the infrastructure around background tasks, because I'm going to call it without you having to wire it up to anything in the system. This will all be done manually. And so you can only have one trigger for a background task. I can say task.addTrigger. Set trigger. And that's the one and only trigger you can have. Now, I can re-register the same background task again if I need to, creating a secondary trigger that might cause it to occur. But I can't have two compound triggers, right? That doesn't even make sense. So, what I can have is a condition. And so if I created a system condition, say like new system condition, I can pick from a long list of conditions, including things like user present. So user present means don't run if the user's not even logged in, right? I mean, that's valuable. I could say don't run if the internet's not available, because I'm going to have to test for that anyway, which is awesome, right? Because I've only got 25 seconds to do all of my operation. So now I'm going to do this operation. I don't even have to test for internet connection, because I know that that's one of the conditions in order for my app to run, or for my background task to run in the first place. And so these conditions are really valuable to save you time.
Technically, the one you're selecting is only if the condition is not. So run it if there's no internet. So you can do one or both.
If there's no internet. Yeah, that's right. Because you might rely on some other process otherwise. Yeah, that's right. All right, so the last thing I'm going to do is register the background task. And so I'll say task.register. Perfect. So now the task is added to the internal registry of Windows, so it's a list of all the background tasks. Where do you see that list? Well, the reality is there's only one place you'll ever see it. You'll see it inside Battery Saver, right? Battery Saver is an app inside Windows. It was on Windows Phone. Now we have it on Windows 10, where you can go in and see all the background tasks registered to potentially take performance away from your system. It allows the user to go in and kind of finesse and tune their system the way that they want. So all these applications, they run them, they install all these background tasks the way that they do. That's okay, the user is still in control. They can go into the background, they can go into the Battery Saver, look, and they can disable, or they can go in and they can actually give a special status to make sure that the background task runs even when the battery mode is on and it's trying to protect the battery. Everything except this one, right? So the user has a lot of control to really create a scenario that they want. So this is my app. This is my trigger right here. And in order to make it work, I would say trigger dot, and I would request async. And so I'll make a wait right there. So two things just happened. In the 2 lines above this, I registered it so the task can run. In this line, I'm saying, now run the task, right? So this is very different than the Windows 8 way of running a background task, where the only way was some sort of external system trigger to occur, then your background task could run, or maybe time, then your background task could run. This way you can take advantage of it here. And because a background task can have 2 triggers, because you would register it twice, you can have one so you register it internally and run it whenever your application is running. And the second one, I could create a second and repeat this code, or not repeat it, just repeat the register part. Repeat this code so that I say, and I want this to run every 15 minutes as well, or every 30 minutes as well. So I'll call it manually here, then I want this other trigger to work in this other place. Yeah, makes sense to me. All right, let's test it. This is really a small amount of code for what's about to accomplish here. We'll see how long a build and deploy takes.
Yeah.
This is Murphy's Law here. This is terrific. It didn't default to ARM. I got to give it credit on that one. It was defaulting to ARM before. All right, so this button is everything, right? The whole action. And see the toast at the very bottom? So that toast at the very bottom is the one that says hi from the background. So that's outside. That's 2 things, right? Not only is it not the same application, not only am I able to call that from somewhere else later with another trigger, it's also outside the scope of my execution context. Is that the right word? Process. Outside of the process of my UI. So as the UI gets collapsed or taken down and suspended, I don't have to worry about the background task getting suspended either. It continues to run. So obviously it's not doing very much right there, but it works nonetheless. And if I had a long-running process, it could go and go and go. In fact, there are different types of tasks, a long-running and short-running task. And the short-running tasks are most of them. This application trigger is a long-running task. And we'll talk about those types here in just a second. Perfect. Okay, so if you didn't look, I just so that you can have it, and this is when you download the deck, this will be interesting to you, so you can have the quick snap of how to just throw up a toast. This is how you just throw some toast up. It's really easy. I will just point out, a toast is defined in XML, and so it is a lot of XML work right here, so that's the idea. Okay, so your application has as many background tasks as it needs. 1, 2, 3, 4, 10, 20, 50, whatever it is, and they each have their own quota, and we'll talk about quotas. But first, let's talk about just some best practices in general. Your background task needs to think about some things, or better to say, you need to think about some things. The first one is to respect the cost.
Pass some parameters to the background tasks.
What a terrific question that is. All right, so the question was, can you pass parameters to the background task? So the only thing that would be able to pass a parameter is a foreground task, right? Because it's the only thing that's active. So the only time you would be able to pass a parameter to a background task is with the application trigger. And that is the only trigger that allows you to pass background tasks. So yes, whenever I called, well, it's on the other thing, but whenever I called request run, or what is it? Well, anyway, whenever I ran it, invoked it, I didn't put anything inside as if it had parameters, but it's overloaded, so I could have passed something. And so as long as that's serializable, that'll be passed automatically to your background task, and you can just recast it in it. In fact, we have a demo of that where I can show you where we pass a number and it counts to that number for you. So you absolutely can, and because it makes it really valuable to do it. If you couldn't, then it'd have to be this generic kind of task that you have to talk to, maybe through static variables. But anyway, yes. So yes is the answer. I'm glad I can answer that one in a yes. The other is so the first is to respect the cost. So the system already evaluates whether or not you can run and whether or not the cost is high outside, right? So how constrained am I going to be as far as resources? You can ask that. And if it says, hey, the cost for you to run at all is super high, so don't expect to get a lot done, right? That's really what it's saying. And so if you do that, then you can just bail right then. You can say, you know what, forget it. I'll do this on my next schedule. That's very valuable to respect that, just so you can have a better experience inside your background task. The other is to handle execution, or to handle cancellation. So cancellation could happen at any time as well. This is just defensive programming for you to be able to go in and say, my application is running, or my background task is running. Either the user or the system has caused it to be canceled. Now I want to stop processing before I get terminated, so you can do it gracefully, right? Also, we'll be in deferral, so this all has to do with asynchronous as well. And you have the ability to send back, not just to the UI, but really to anything that's listening, whether or not your application, or whether or not your background task is working, so they can see 20% done, 30% done, 40% done. This is what it looks like whenever you're asking for whatever the current cost is. If it happens to be high, that means the cost is extremely high for you to run. You may not even want to run anyway. Cancellation is a little bit different, right? We have the canceled event, and then this really depends on what you're doing. I can't show you how to cancel your own task because I don't know what your task is going to be doing in the first place. But what you can do is set a variable that you check later or somehow signal your own process so that it cancels in a graceful way. That's the nicest thing to do. Just like suspension, when we got the deferral so that when you release that method, it doesn't automatically terminate, you want to do the same thing so that you get a deferral so that you can do asynchronous operations as well. And so there are two things inside a background task that are worth talking about, the trigger and the condition. And so the trigger is the trigger is the thing that causes it, right? That's the one thing that you have that causes your trigger to fire. And the conditions are the things that say as long as, right? As long as these other things. And you can have multiple conditions. And so the first thing we did, remember in the sample, was I requested access. It used to be that there was a UI that would ask the user, do you want to allow this to have background operations? That is no longer the case. There is not a UI for the user to have to interact with. You can just register your background task and your application does a good job, right? That's what we want. It just happened to be that way at the beginning. Those have all been removed now. And so this is the syntax we went through to build it, and where we talked about canceling on loss. This might be particularly true if what you rely on, something like the internet, suddenly falls away. You don't have to constantly test again and again. And we also have this ability over there on false to make it so that a trigger is one time. So I can say something like, as soon as you don't have internet access, I want to do something. But never again. So I'm not setting up this endlessly recurring trigger. I can set it as a one-time type of trigger. And then because a condition is just a collection, I'm adding to the condition collection before I register it. All right, so here's the life. Execution is both trigger and condition. In Windows 8.1, these are all of the triggers that we had. And it was quite a list, actually. We could accomplish quite a bit. Then along comes Windows Phone, and we could do even more. All of these different triggers, each one kind of pertaining to different scenarios that your app might be able to use. And then Windows 10 comes along and introduces even more triggers for us to be able to use. It's actually fantastic. This list is extremely long, but when you start looking at it, most of the names are really clear what they're accomplishing. They interact with Bluetooth, or they interact with some sort of sensor, or maybe it's the Action Center for notifications. The one thing to know is that there's a time trigger. This is the most popular, of course, right? I want my trigger to fire every X minutes. You can't go any shorter than 15 minutes, but you can certainly go longer than 15 minutes. And some interesting things happen if your task is about to fire. So your task, you say, I want this to run every half an hour. And then the user turns their computer off, right before you were going to run. And then they leave it off all night, and they turn it back on. Well, that was an 8-hour period in which you would have run 16 times. Now you haven't run any. What happens when the user turns their computer back on? The answer is...
It'll continue.
That's right. It will run. It does actually run, but it doesn't run 16 times.
No.
It just runs the one time it should have, right? If you start to stack them up, it discards the old ones and you get the new one as well. So that's the idea of you get your background task execution no matter what, but there is another idea around latching. And so this is a phrase that we use to describe when your trigger fires, but your condition doesn't fire. So, for example, I want my trigger to fire every 16 hours, right? It's a long time. And 16 hours just happened. I'm like, yes, only when the internet's available. There's no internet. Does that mean my task won't fire for another 16 hours? No. It latches. So as soon as the trigger occurs, it now waits for the condition. So it may be another hour before the internet finally comes back, but as soon as it does, then your task will run almost as if they had turned the computer off. So this is the idea of latching and waiting for. If the time period occurs, so the 16 hours happens again, and now you have two tasks latching, obviously the old one gets thrown away and only one latches at a time. Yes?
If I wanted my task to run every 5 minutes, could I fake it by spinning up 3 tasks and having them run 5-minute increments? You know what I mean?
Who are you, man? Oh my gosh. All right, the question was, can I break the rules by having 3 tasks? One that runs on the 5-minute interval, one that runs on the 10-minute interval, one that runs on the 15 minutes, so I run 3 times in 15 minutes. Yes, you can do that. Yes, you can do that. Good Lord. Definition of evil. All right. Terrible. Absolutely. Yeah, exactly. Sith Lord. All right. The maintenance trigger. This is a type of trigger that we have. So this is one that people use all the time, right? Every so many hours, I want to make sure that we download the latest database so all my drop-downs are up to date. Okay, that's a maintenance trigger. And what's great is the maintenance trigger will only work if it's plugged in, because your maintenance trigger is pretty heavy duty. And that's what you want to say. You want to say, okay, I want this to run, but I don't want to destroy the whole experience for the user. Wait till they're plugged in, then run my maintenance trigger, and it will. That's what that's meant to do. It's another one of those long-running tasks, a very special type of task that doesn't end until it's done, unless System Resources forces it to be ended. Sorry. So here I am adding a trigger. We did this once before. And then it's the idea of conditions. And remember, you don't have to have a condition. That's up to you. Right? So here's the conditions that you can have. And you can have more than one condition if you need to. Internet available plus internet not available. I don't understand both of those together, but you could do that. I'm sure you want to, but I don't understand necessarily why you would. All right, so here's registering with a condition. We showed this, how you just add it as if it was already there. Once a trigger is fired, it waits for all the conditions. Remember, that's that phrase latching that we had before. All right, so now it's a matter of resources, right? And so there are constraints in background tasks that make it so that you can't ruin the user's experience. What are those constraints? Here they are. First of all, there's no CPU time quota. The reason I put that up there in the first place, because in Windows 8 there was a CPU time quota. You could only use 2 CPU seconds every 2 hours. That No, you could only use 1 CPU second every 2 hours unless you were a special type of task. You could use 2. CPU seconds go fast, and it's weird. So it's all been moved over to something we can understand very easily, just the wall clock. Now you have 25 seconds for the wall clock. Do you have any CPU guarantee? Absolutely you do. You have 10% CPU guarantee. The rest, maybe, maybe not. What that means is other background tasks will be allowed to execute at the same time also. Or, better said, if other background tasks are executing, you can too. It does mean there's a limit of simultaneous background tasks that can execute, but it means more can than can't. I think the number is actually around 8, not 10, because you would suck up the whole machine. There is also a memory quota. The memory quota, on the other hand, I can't just say what the memory quota is because the memory quota is specific to every device. The memory quota on a gigantic, awesome desktop is quite high. The memory quota on a tiny little 256 megabyte phone is 16 megabytes. So you can see at least what the floor is, right? The lowest possible memory quota that you'll ever have is 16 megabytes. There's also a type of network quota, but it's not even worth mentioning here because the variability is so crazy high. Every time your trigger fires, the quota starts over. This is brilliant because this is not the way it used to be. It used to be you'd have 2 tasks in 2 hours. They would have to share the quota. That is brutal, especially if you had 10 tasks in 2 hours. Now, every time your task executes, it starts over, so you can rely on 25 seconds, right? There's 25 seconds plus 5 seconds is the idea. And maybe this will help make that more clear. Your trigger fires, and it starts to run. 25 seconds goes in, and you get the cancel event. The cancel event is basically the, hey, you've only got 5 seconds left event. And then you have that 5 seconds to either clean up or write to the log that you couldn't finish, right? One or the other. Hopefully you get it. On the other hand, there's the long-running task. And a long-running task also starts the same, right? That's beautiful, with no end in sight, right? And all of a sudden, resources get constrained. And what event are you getting in the long-running task so that you can clean up real nicely? None. You just get the rug pulled out from under you, which means you need to be much more diligent around your defensive programming to make sure that if it does happen to end, you have already written that it wasn't complete, and at the end is when you write that it was complete so that you already have that logged. The nice thing to know is this is just the way it is today. Windows 10 is a massively evolving operating system, and there will be an event for you. There just isn't now, so this is sort of a nice little nod and warning for you. Background tasks can be canceled, and they get 5 seconds no matter what. Your 25 seconds you get, but then you get the 5 seconds. It is possible for your background task to be executed early, even though you have that 25 seconds, right? It really depends on the performance of the... Your system would need to be a serious bad situation if that happened, though, so you don't have to think about it. All right, so when your background task runs in the blue down here, it's in its own process. When your foreground task runs in the pink up top, that's in its own process as well, but it doesn't have to be that way. They can both run inside the same process, which is great. That means static variables and shared classes can all be used, and they will have the same value across each, and you can communicate back and forth to each other. That's really useful, especially if you're using it for something like database interactivity, right? And you want to make sure you can close and open them and don't have 2 of them open at the same time when your foreground and your background are both trying to work. You don't have to worry about that. You can put it all in the same process. The upside is you can do that. The downside is if your UI gets canceled, so does your background task, because when the UI gets canceled, the process gets pulled out, right? And so your background task doesn't hold it in there. That's just kind of the way it goes. Here, this will help also explain another caveat that we're thinking of if you are wanting to put it inside the same process. If you do put it in, if you don't put it in the same process, your task looks like this. It starts, it runs, then it has that little 5 seconds to end. Good job. Then it does it again. Then it does it again. But you might be running your foreground task at the same time. That's okay. They'll both run together. They're not in the same process. Everything is okay. This is the normal execution. But maybe you decide to put them inside the same process. As soon as you do, the memory usage now is in a single process, right? It's not broken out because they're no longer a separate process. Now you have one memory block being taken, and what it might mean is you go over the memory limit and your application is subject to being terminated. Remember, Windows is always looking at memory usage to make sure the user's experience is awesome. And if you are the culprit of why their experience is not good, you will be terminated. That's just the way it goes. And so you want to think about how much memory consumption your application already uses and whether or not you can afford to add a background task onto that.
Yeah. And that's just the reminder that you shut down the UI, so does your in-process task.
Yeah, that's right. There are a couple other constraints that you should know about, and the first one is quiet hours. It was first introduced on Windows Phone, but now we have it on Windows. Quiet hours is me saying, between the hours of 6 and 6, let's say, 6 to 6, 8 to 6 maybe is more realistic, I don't want any toast notification. But I also want background tasks to be quiet because I want to make sure my battery is okay in the morning. And so now, all of a sudden, there's a new set of constraints that might actually pull down your background task and prevent it from running, especially if you've only set them to run at midnight. Now, why is my task never running? Maybe it's because of quiet hours. The other one is around battery saver, which we talked about before, where the user can go in and proactively set certain background tasks not to run. Because battery saver tells them in a graph who's using all the time here. And if all of a sudden your background task is the largest in the graph, they'll be tempted to disable your background task.
So can I slot the required hours in the sense that, in the morning when I wake up, I don't want my phone to suddenly, start over or suspended. So is it like every 2 hours or 3 hours once?
No. Hey, so the question is whether or not quiet hours is one block or several blocks. And it's one block. There's just quiet hours. Yeah. That's an interesting idea, though, to have separate blocks like that.
At 8 o'clock in the morning, suddenly
Sure.
start breakfast and then they all shout around, right?
Now, it seems like waking up in the morning is okay. Just kidding. Yeah, I get the whole point.
What? I don't understand that message. We just talked about battery saver. Why is it saying it still returns approved?
So when I go into the background execution manager and I say I request to be able to add this to the registry, the background or the battery saver may actually prevent all background tasks from running, right? Because that's the way the user has it set up. Well, I still will get an accept, right? This is not a way for me to test whether or not the battery saver allows me to or not to be executing. Because when I'm asking to be added to the registry, I am allowed to be added to the registry. That's what it's about. It's not whether or not I'm allowed to be executed, but it's an easy API to read incorrectly.
That's correct.
And I think that's the whole deal. So testing for quota is a tricky thing. Testing for memory quota, the API has not been documented yet, so I can't tell you what that is. But there is also a way to ask for disk quota, and its API hasn't been documented yet, so I can't tell you what that is. But I will tell you, just as an aside, these are good things to look for. If you're about to do a gigantic background transfer of a file, it's great to test whether or not you have space on the disk or not for it first. Or if you're about to do something and you know it's a heavy execution and you need to check for memory usage, it's great to check your quota. And you can basically say, do I still have quota? Do I still have quota? Do I still have quota? And it'll give it back a yes or a no. You can do all the math as well, and it kind of depends on how savvy you are with memory management.
Visual Studio is awesome for debugging. I mean, literally, it is. It's awesome. When you go and you start and run a process, you also have the ability to explicitly run a background task and do some things like that. So it's very nice.
That's right. When you go into your project, you set do not launch, but attach when launched, right? And so I click the play button. It looks as if it goes into debugging mode, but your app doesn't launch. Now the trigger fires and your background task starts to execute. Visual Studio will automatically attach to that background task and allow you to step through it. That's very powerful. And if you don't know the don't launch but act like you launch button, I can't remember how it's actually worded, in the debug tab of your project properties, there's no other way to step into your background task. I'm going to jump to the background task. Is worth at least pointing out a couple of things that's been highly enhanced. One of the things that you get to do with the background task now is pass credentials. That's a new feature that we didn't have in Windows before. It also allows you to have extremely large files that wasn't there before and handle different verbs for when you're calling out to a REST service for it as well. That's important. So here is the syntax just so you can kind of see it. But obviously, you're going to want to implement this on your own. There's two things that are worth noting. One, as a file is streaming down to your device, I can tap into it. I can tap into that stream and play it in the media element, which means I'm downloading a large video. I don't have to wait for the whole thing to download before I can start playing it. That's valuable. The other thing, and probably the coolest thing, is that I can set up a toast notification and give it to the background task ahead of time and say, once you're done, I want you to pop up this toast. And maybe the toast says something like, your video is ready to display, or something like that, right? Whatever it is, what you don't have to do is listen to the background task, wait till it's done. As soon as it's done, queue up a toast. This is just a built-in mechanism that it's just a common task that people do after background transfer is complete. I see you. Hang on just a second. You could have more than one background transfer queued up. This is particularly important, especially, and upload as well. This is particularly important if your application is a file management system and you know that your application often gets terminated. So if you're OneDrive and you need to do a whole bunch of file work, you can queue it all up and then you don't have to worry whether or not your application gets terminated. One of the most valuable task types that we had on phone is now over on Windows. That's because everything is on everything, right? There is no longer, can you do it on phone? Those questions don't even matter anymore. So XAML rendering background task allows me to build a UI, a tile, let's say, that looks exactly the way I want it to look. Just absolutely beautiful. I'll use XAML for the whole thing, render it as a bitmap, and then I'll pass it to the tile. That's a special type of task that allows me to do all this interaction, gives me access to the namespaces that I need. And now it's on both. So this gives you a lot of flexibility around live tiles for sure. This render allowed, well, there it is, right? You pass in the element and do it, for sure. The background task used to be assumed, and this I have taught this very thing myself by mistake, is that the background task has to be written in C++. That's not true. There's a couple of reasons. One, C# is awesome, right? We now have Project In, or .NET Native, which allows us to use the C++ optimizer and run almost as machine code now writing C#. That's one of the reasons I can write these background tasks in C# and be comfortable with it. And the other is, maybe I'm not updating every single tile. Maybe I'm just updating 2 of my tiles, 3 of my tiles. That's fine. You can totally do that in C# and not worry about super optimizing with C++, right? But if you look at all the samples on the internet, they're all in C++, except the new ones. The new ones now are in C# because you don't have to do it. This is a common question for Silverlight developers. Silverlight developers who wanted to move over to WinRT on their phone didn't have the opportunity to because the background task was not ported over to WinRT yet. There are no blockers like that anymore. This is just one of them, and the idea is I can now do background audio. It's not that big of a deal. Every single task type is available across every device.
This is one, I was chatting with someone prior to this starting. We won't have time to go into this, but if socket level information is important to you, there is a build session where this topic is addressed in more detail, but it is very fascinating and it is highly and vast improved.
In fact, if you are an enterprise and on the inside of your enterprise you want to use push notifications, push notifications allows you to push things to devices. It's very valuable. But some enterprises, they're locked down, right? That's not an option. They don't want to use Windows notification services that's outside. That's just not an option for them. That's fine. That's where the socket trigger really kicks in. I can build a socket server, right, where I open up sockets and talk to devices just fine. And what happens is I have a foreground application that opens that socket and then hands that socket off to a broker. And then I tell the broker as it takes it, I say, now, if anything comes across that socket, I want you to activate this background task. Right? That background task can receive that socket and interact with it. So just like a push notification, that is exactly the way push notifications work, by the way. So just like a push notification, something comes across that socket that your server sends, and now my device is listening, not my app, because my app's not even running. The device hears it. The broker knows what to do with it, activates your background task, and just like a push notification, your application is running as a result. Right? It's very powerful. Very powerful. All right, let's look back. What did we talk about? We talked about extended execution. Remember, that's our ability to formally ask the global pool to give us resources that it has so that we can extend the way that we work. Either our suspension gets longer so we can save a little bit more data, or so our application never gets suspended because we're a location type of application. There are so many new triggers, and tons of them have to do with new capabilities of Windows 10 as well. Those will all be documented on MSDN. We're still in preview right now, but all those things will be documented on MSDN as soon as Windows 10 releases, as well as the new tasks as well. So these new types of tasks, many of which were Silverlight tasks, got brought over, so now everything is inside the Windows family. All of these, no exception, run on every device. Mm-hmm. If you heard of one that was interesting, and I'd love to put it on my app that runs on the HoloLens, terrific. If you're writing a Raspberry Pi application and you really wish you could use that sort of task, you can. Everything is the same across every device. This wasn't the message we got to give last year. Last year was this complicated grid of what runs where. Now, if we build it, you've got it. It's just terrific, right? Obviously, certain hardware will have certain limitations. We can't get past that. Windows isn't hardware, it's software, so if you don't have a camera, we can't activate your webcam sort of thing. But if it's there, we'll give it to you. All right, resources are still limited. Remember, this is all about the user, but you can take this away and just know, right? Then you can have the summary in your mind of, you have 30 seconds, basically 25 seconds plus 5, right? You have that 25 seconds to run and that 5-second warning after you get the canceled event. Then it's over. And you have 16 megabytes as your bottom floor of the lowest type of device. That 256 megabyte phone is the lowest type of device. A Raspberry Pi is better than a 256 megabyte phone. It doesn't matter. But if you can remember just those two, you've kind of got your head wrapped around all the quotas for background tasks. Make sense?
Sounds good.
All right.
I think that's it.
We are absolutely going to be here to answer any questions if you guys have. We're going to go ahead and dismiss you, and then we'll stay around, and you guys can ask anything that you want.
Thank you.